Okay, I think it's time to start. Welcome, everybody. I'm surprised to see so many people here. There are some awesome other sessions going on right now, and I'm surprised you chose this boring topic. My name is Anton. I work for Zero Turnaround, and I'm a developer advocate. I used to be a developer and a product manager of the tools we develop. We are famous for JRebel. Some people know that we are also developing XRebel and some other tools as well. But those are the main ones, and I used to be a developer and a product manager for both of them. And the talk is somewhat related because we needed a good tool to actually test our products. And well, you will see how it turned out. So integration testing, does it actually matter? How many of you are actually doing integration testing? Nice, everybody. So that's why you came. So there are different opinions whether you should or should not do integration testing, and why couldn't you just get away with unit testing? Why? Can anybody tell? It's not enough. Well, it's a good argument. You know this guy? J.B. Reinsberger. He's famous for his JUnit receipts book and talks about unit testing and so on. And he would say that integrated testing is a scam, because if it's not enough that you test it with unit tests and you still have to write the integrated tests, then it means that you just did not write enough unit tests. Well, it's a nice position, and he has a good argument about this. But they are real life, and we have to be practical sometimes. Well, here's 2 unit tests, 0 integration tests, right? And the same is here. This is my favorite. Right? So how many times it happened with you that you actually developed a unit test, like many unit tests, you have a coverage of 100% and it still fails? Happens, right? Every time. Works on my machine, right? So it actually needs a reality check. I mean, your component, whatever you developed, your application, especially if it talks over the network. So you may even use it as a condition for the integrated tests. If your application has to make a network call, then it's an integrated test, right? So by real, I mean you should use databases. You should use real databases, file system, network interfaces to actually check how your application works in a real-life condition. So when I joined, I discovered that in JRebel there is almost none unit tests. Like everything is integrated tests, and a huge amount of those. And I thought that, hey guys, why are you not doing any unit testing? And they said, okay, you try. And I tried, and I failed miserably, because what JRebel does, it integrates with all ecosystem. It builds in the hooks in the frameworks, it instruments the class loaders, it builds into the application servers, and there, just checking that you built in some kind of a method inside a framework, just checking how that one works is just not enough. You have to test everything, like how the life cycle of framework, is it affected? Does it actually do what is expected to do with that method, and so on? So it was just not enough. And here's how the typical JRebel test looks like. So it's kind of a simplified version of it. So we start the application server, and to test if JRebel works normally in normal conditions with the framework or with the server, it will actually deploy a web application. Of course, the server is started with the agent, but when we deploy the application, we verify the initial version if it behaves as expected. It's not changed yet in any way, so it's an initial state. And then we compile a version 2 of this application and check if the new behavior is there. And then we may have another one and test again, and maybe deploy another application again on the same container. And well, at the end we have to clean it up. So it's quite complex already. it's testing on the level of a web application, how it interacts through the whole stack with the server, with the framework, and so on. So it's too many different pieces in one test, so it's kind of an integrated test. Not kind of, but it's really an integrated test. From there, I kind of got a few requirements for this kind of testing. Basically, what we need a reproducible environment first, right? It's an obvious thing. Then it should be actually reproducible for both development and CI. It shouldn't be different, like in an ideal case. It should be the same environment that you use on your local machine on a CI server, because if you have a lot of servers, you should be able actually to clone this environment in many machines, different operating systems, and so on. So it should be isolated. So if the same test with the same environment settings is running on the same machine, same physical machine, it might compete for the resources, like occupy the same port, for instance, right? So it will just, conflict and it will fail. So therefore, we need to find a way to isolate those. And it should be as real as possible. I should actually replace this one with it should be real, right? In the best case, but let's lighten up it a little bit so it can be as real as possible. And it should be a cross-platform because we have to test on different operating systems, because our tools, our products are actually used by developers who are using, Linux, Mac, Windows, and they have their own different, specifics. And it should be also easy to set up and maintain. So when you have a new team member coming in, he shouldn't spend a lot of time on setting up this environment. He should just clone the repository, start it, or open in the IDE, start it, and it should just work. Too much, like to wish, right? So how much time you actually spend on setting up the environment? 5 minutes? 1 hour? A day? A week? There are some, right? It happens, I know, it happens. It happened to me as well. So one obvious thing that comes up to my mind is like Docker, right? So it gives us the isolation, it gives us the way to reproduce the environment. Why not? Why not to use Docker? So we actually started our own way to automate all this, because it's easier to set up. Once you have Docker environment installed in your machine, which is quite easy to install, then all the other dependencies is like easy to manage. They are just pulled in. The images are pulled into that Docker machine, and we can fire up the dependencies inside Docker. But there are some complications as well. So, but here, like if you have a complex environment, you have many dependencies. Docker Compose is like a very nice feature, right? So you have just one file. You declare that you need those dependencies, those databases, maybe application servers, and it gets you that, right? So it fires it up, you can test your application. However, again, remember about the concurrent test execution and continuous integration environment. What's wrong there, right? The ports are hard-coded, and in CI, you actually need to randomize them. So it's not that easy. You end up like fighting the environment, and at the end, it's not so nice. Even though, like you in the beginning thought it's a solution. Damn, the light is too strong. I should put a cap. Okay, and there is one tool that we discovered when we started with our own way to automate the containers, is the TestContainers. So our developers started to contribute there. They discarded their own idea how to automate Docker and started to merge their own ideas also to that project. So we have some contributions to this one, and this is why I'm kind of talking about this tool here, because Zero Turnaround is basically using TestContainers for everything now, for all the projects. So how does it work? It wraps a Java library that actually talks to a Docker environment, and it can discover the environment. So like basically using the environment variables, it will discover how to start Docker, and it will start the Docker machine if it's not started yet, and well, it will clean it up for you as well. So it's like, it becomes very easy to manage all this, setup on your machine in the CI environment as well. And it's as simple as this. So generic container, this is like a basic API here. The generic container is like a flexible container. Basically, you can just give it a name, right? Redis and some version, and it will pull in the image from the repository and start it up. And once the JVM is shuts down, then it cleans it up. It shuts the container, and everything is clean again. And you may have all the like many different throwaway versions of the database containers. So for PostgreSQL, for MySQL, for Oracle, for anything else, like which is bundled in there. There's even one for Couchbase. And let me show you a small demo, how it looks like. So I try to live code it at first, and then the rest of the demos I have, we'll just look at those instead of live coding. So does it expand somehow? No? Nice. Visual effects. Let me try it this way. No? Well, it hanged. Turn it off and on again. Kill it. Yes, I killed it. Well, you know, I'm running on the latest alpha versions of IntelliJ. What could go wrong? It's the AAP version. Is anybody using AAP versions of IntelliJ? Yeah. I like to live dangerously. Okay, it starts. Please start. Okay, the visual effects are gone. So we have, oh. That's interesting. Probably the projector acts somehow. Let me try again. Yes. So, GeeCON demo. Nice. So I have, it's a basic example. You will find it in the tutorial as well. But we have a Redis backed cache. So it's kind of just an interface to a Redis instance that will be running in a separate process, right? And it just has like a get and a put and a get method to take some data out and put some data in. And let's have it here like something like a cache test. By the way, are the fonts okay? No? I think you can see it, right? Just in case, I will do it like this. So let me get a generic container, right? So I have one, the same as it was in slides. Then I can set up my test first with by getting the IP address of the container that will be started, and then I get the mapped port as well here. So I need also to declare it as a field. Boom, so I have that one. And now, when I will start the test, during the initialization, it will pull in the image, right? It will expose the port that I just declared, and it will start the tests if I have them, right? And then when it shuts down the JVM, it will also clean up the container. So let me have one test. So okay, import, Visual Visible Assertions. Right. So if I start this one, please start. Run. It will be interesting to see what will be the output. If it runs, what could go wrong, right? So you see that it pulled in the image starting the container. It's flickering a little bit. So it's starting the container. It started the Redis container. It ran the tests. So those visual notifications are from the library that is used here, the helper library. The assert equals is the one, just the custom assertion method that will display these nice messages. And then it runs the tests, it cleans up everything, and done. So if I go to the console again, let me do this test docker machine clear docker machine less. We'll see, the machine is stopped. I have nothing running, so it cleaned up everything. This is like a hello world here. Any questions yet? Yes, one? Currently it takes them from the central repository. The Docker registry, if your repository supports Docker registry, then it's possible, yes. All right, so let's proceed further. So, what about Docker Compose? Anyone is using Docker and Docker Compose? Nice, right? So it's a nice thing to declare all the dependencies that you need. And obviously, you probably want to reuse them for the tests as well, or somehow just, separately declare them in a separate file. And then it's possible to use this Docker Compose container to basically, do the same stuff that we did just in the previous example. And the only difference is that you then have to ask for the service host and service port by the service name, and the service name is kind of a fictional one, right? So it's an automatic one. So, are you excited yet? Yeah, it's a nice thing, right? Okay, so here's another example for you. Testing of microservices, fancy stuff, right? So you have many dependencies, and let's say you are developing those in Spring Boot. Are you developing microservices with Spring Boot? Okay, someone will learn something, and well, imagine you have like database dependencies, Redis, Postgre again, and probably there is this little cloud there. This is another microservice that you probably want to use for your testing. And then, well, it will be an interesting moment here because you only want to test this Spring Boot application, but not the other application. You want it to be isolated, right? So if you test too many applications at once, it's not really isolated test anymore. So it's not even integrated test anymore. It's kind of a functional test, like end user test or whatever else. And we want this to be isolated. So if you are using Spring Boot, you may just still use all the same goodies from Spring, right? Anyone recognizes this? Right? It's just the standard feature of Spring Framework that it provides you this kind of goodies. And then you can declare your dependencies. So I'm not using Docker Composant here, but just declare those generic containers and a dedicated database container. And you see there is also like a mock server container. So we actually will mock that one microservice that we want to talk to, but we will mock not on the driver level, so we are not stubbing it. We will still have a remote process running in a container, and our own application will still talk remotely to that mock application, but it will be kind of isolated, so it doesn't depend on a other real microservice to finish. And then we just set up the environment the Spring way, so nothing fancy here. So what's mock server? It's actually a library available, it's open source, and you can use that just to mock the remote application and tell it to respond with an appropriate response when you ask something from it. And how do we use it then? So just for the convenience, we don't really need to create our custom container, but this is just for the convenience here. We'll say that we extend the generic container and we pull in the image, like in the constructor, right? We declare what is the image that we need for this mock server. We expose the port, and then the generic container actually provides us the lifecycle with this container is started method, where we get the notification basically, okay, it's started already, we can initialize something else, initialize the client, and then in the test we can use this client to actually, you know, communicate with the mock server. Nice, isn't it? So we get the isolation there. We isolate the databases, those are real. We are not dependent on some kind of a microservice or any other application that otherwise may fail and make the test more complex, but we want to test a certain, like one thing, one functionality inside our own application, in this case a Spring Boot application. All right, good, right? So clap everyone. Yes, I'm on fire. Okay, so here's another use case. It's not really kind of the use case that we need, but sometimes more like a user acceptance testing through the UI, right? Selenium, Selenide. Have anyone tried Selenide yet? It's a Java wrapper around. It's a nice API around WebDriver. And you can write nice fluent API in Java. So, and then testing with real browsers is kind of a good thing to have, right? But there are some complications. For instance, the browsers are auto-updated. Sometimes your tests start failing, and once they actually fail, you need as much information as possible to debug those. Or if your test is failing, or your test failing for some other like conditions, not functionally failing test, but you know something is flaky and you want to fix it. So, and it's also like CI friendly because the requirement for this one is to run in a headless mode. So you can actually run in a headless mode and get your tests running. So how does it look like? The API is this. So you have a browser WebDriver. It's also like an isolated container. And then you get the real driver from there. And then you use this driver as normal, you know, as if you would be writing some kind of a test as normally, right? So you don't really change much in your test. You just add this browser WebDriver container to start from somewhere, right? So it actually bootstraps your environment, and then you don't really change your code anymore. Not bad, right? Okay, so before we actually go, I want to show you that, how it actually works, because it's a really nice feature and it really has nice capabilities in there. So Java boilerplate. It's also the example from the repository. So if you want to play with it, you will just find it and oh, sorry, wrong one. So yes, here's the test. So exactly the same code as I had on the slides. Let me run it. It runs. The startup is a little bit slow, especially when you run it for the first time, because it has to pull in the image. But once you did it for the first time, it will be just fine. So you will see in the log that there is a dependency on VNC recorder. Wow, it will actually record the video of the test execution. So yeah, it finished. It actually recorded the video automatically. Let me see, do I have it somewhere in front of me? So it's a short video. The startup is a little bit slow, but you will see how it works soon. The browser starting, and then the whole scenario is executed. And it can pull it from the container, right? So it was running in the isolated environment, and it gets the results back to us. Really not bad. So there is another use case also. This is actually the real use case we had, because we have to test our agents. And there is a small demo application in GitHub that can actually demonstrate. It's cleaned up from all the complications, and you may try it and understand it easily, but I will explain it as well. So how many of you don't know what the Java agent is? Some of you don't know, right? So there is a Java, like a feature of Java virtual machine that you may write a Java agent, which doesn't really manifest in any way that it is an agent, right? So it's just a convention. It implements the pre-main method, and when you package it, you should say that there is a pre-main class that implements the method, and when you start the application, you provide it with -Java agent and the path to the jar. So our products actually bootstrap this way, and they instrument something in your application and then provide you some kind of a feature, right? Jarable provides the class reloading, and Extrable provides application profiling. And this instrumentation instrumentation interface is provided by the VM. So it's basically a hook into class loading, where you can define your own class file transformer and do something with it. So here's an example of a transformer, just a demo. So for every JT handler, it would inject a header, right? So in this example, we use the JavaSys library, but it could be any other library. And the only important thing is those 2 lines right now. So when the embedded server actually handles the request, it will put the header, the custom header, in the response. So that's also one functionality that we need in our product, because Extrable can trace the requests. So we are using it for that. And how it looks like. So the basic test would be something like this. We may implement a custom container. I will show in a minute how it looks like. And then it just verifies the behavior. So all the magic is, somehow isolated. And let's see how it looks in the IDE. So here's the test, right? This is the agent, right? And the build script will actually tell that this is the pre-main class, and it should be the agent. Now, the test is the same as I showed in the slide, and the basic test app is actually the container, which uses a script, right? And the script is a test application that we will be running with. We are testing the agent, but to test the agent, you actually need some kind of a application to be instrumented with the agent. And in our small tests, we are actually using Groovy to test that. So app Groovy is this, right? So it's very convenient way to build small applications. And this Groovy test app is just, bootstrapping the real container and bootstrapping the agent. So it maps the file system. It provides us the Java agent property with the environment, and it tells, okay, we are using this app actually to run our test. So if I run it, where am I? Okay, Gradle test. So it's basically the same again, right? So I'm starting the application inside the container, I can automatically put there the agent, because I declared so in my test. The test runs, we verify it through the result of the request to that web application. And then we clean it up. Done. I think it's awesome. Chuck Norris approves, right? Done. So I'm actually finished. It's a short talk. It's the last talk of the conference. You had beers already. I did not intend to spend too much time talking, but you can ask questions now. And if you want to ask questions afterwards, I have the contacts here. Anyone? I can show you the animated GIFs. You know. All right, so maybe I'm just too shy to ask right now, but you can ask later. Thank you very much for coming, and I hope you enjoyed the conference.